Welcome back to ZOS Introduction. This is the 23rd video in the series. The learning objective is to describe key controlled protection for all the concurrently active address spaces. A ZOS active program has a program status word, PSW, which contains program control information. One PSW field is the PSW key. As you might suspect, operating system programs need much more authority than application programs. An application program is typically using PSW key value of 8. Operating system programs and critical subsystem programs can operate with an assigned PSW key value that is less than 8. Operating system programs and critical subsystem programs are assigned a PSW key value where the program PSW key value is either 0, 1, 2, 3, 4, 5, 6, or 7, depending upon the specific component program. The pages available to an address space do not have equal authority. An application program created pages can be modified by the application. The common pages previously created by the operating system cannot be modified directly by the application program. System integrity is defined as the ability of the system to protect itself against an unauthorized user access to the extent that security controls cannot be compromised. That is, there is no way for an unauthorized program using any system interface to bypass, store, or fetch protection, bypass password checking, bypass RACF checking, or obtain control in an authorized state. An authorized program in the system is one that runs in PSW key 0 through 7. An unauthorized program is a problem state program that runs in PSW key 8 through F. Several situations exist for private storage area page isolation. While common storage area pages are isolated from the application program operating in processing key 8, which can only modify the address space private storage areas in key 8, a key value of 9 is available for isolation of other private area storage pages. An example is a started task application that is a transaction processor where users can start a transaction within the address space. To ensure a user transaction within the transaction processor address space is only able to modify pages created by the transaction, key 9 is available that would prohibit the transaction from modifying pages in key 8 owned, which is controlling many user-initiated transactions in the address space. In summary, many programs and users are competing for the use of the system. So how does ZOS preserve the integrity of each user's work? One technique is through the use of multiple storage protect keys. Under ZOS, the information in central storage is protected from unauthorized use by means of multiple storage protect keys. You are better able to describe key controlled protection of address spaces. Thank you for your time.